Hi everyone, today's lesson is a chapter review. For chapter 1, we're going to be taking a quiz, and so we are reviewing for that. That's what today is all about. So starting off a bit of a warm-up, talking about functions, parent functions, finding the domains and range of these parent functions. So what you have right here, f of x is equal to any number, like y equals 3, y equals 2, something like that, or just even a negative number as well. When you're finding the domain and range, what you're doing is your domains, remember, go from left to right, and ranges are low to high. So it's really important that you distinguish the difference between the two. For this one, domain, if you were looking at left to right, your domain is negative infinity to infinity, whereas your range is whatever value, whatever number is right there. For a parabola, that's your f of x equals x squared. And for this problem here, your domain also is negative infinity to infinity, but your range only goes from 0 up. And remember, for this value here, these values are just going to keep going up. And so every time, for a domain and range in this problem, this is going to just keep going up higher as those values of the range go to the y-axis. For this graph here, this is a square root. And when we talked about this in class, we talked about square root of 0 is 0. This is fine. This is a function. But remember, this isn't a polynomial because this isn't continuous. It actually stops. But this is all about functions, so not polynomials in this problem. The domain then is going to start from 0 and go to infinity. And, again, these values are just going to be pressed down to the x-axis. So what all the x-axis values are go from 0 to infinity for a domain. For my range, they go also 0 to infinity. Keep in mind that 0 is included, so that's why you see the bracket. For the absolute value, which is the straight lines like that, arms, it kind of bounces off the x-axis. Again, this one would not be a polynomial, but it is a function. The domain also, all reals left to right, negative infinity to positive infinity. The range goes from 0, starts at 0, and then just goes up. Because remember, all these values here are going to go back to the y-axis. For this problem here, this is y equals x cubed, or f of x equals x cubed. This is a cubic function like this. It is a function, and it is also a polynomial as well, by the way. For this right here also, this is going to be negative infinity to infinity, and also same value for my range. For a cube root, however, yes, it's a function. All of these are functions, by the way. Yes, it's a function, but my domain, is going to go left to right. So that's going to be negative infinity to infinity, as well as my range, which is going to drop down, and up high is not going to stop. And so that's also infinity. For this graph right here, this one, which is the f of x equals 1 over x, this value right here, also a parent graph, also a function, definitely not continuous, meaning there's a gap in the middle, so it's not a polynomial, just for review. But for this function, if I wanted to find the domain, remember, it goes left to right. So this would be negative infinity to this value right in the middle. And in this case, for this value, you need to know that x, because x cannot equal 0, because my denominator cannot be 0, I actually have what's called an asymptote right down the middle. There's also an asymptote like this for when the value on the denominator is larger than the numerator. That's a different chapter. But what your job today was to figure out what the domain and range was for this value. And so what you need to remember is that this is going to go from negative infinity to 0, not including 0 because it's not going to touch the actual axis. And then it's going to start up again and go from 0 to infinity. Likewise, my range is going to go from negative infinity to 0, and then it's going to start up again and go 0 to positive infinity. Okay? Graphing the function, this is a y is greater than 2x plus 9. So in this case, we know that 9 is my y-intercept, so I'm going to put a point there. I know my slope goes up 2 and then over 1. Now, be careful here, because do you see this right here, that greater than? Because it's not greater than or equal to, that means it doesn't include all the values on the line. It's only includes values that are greater than. So what that means is for this problem is that this right here is not a solid line. It's a dotted line, okay? And this graph has a shading because it's greater than. So that means that everything on top of the axis is true for this equation. So you might get asked a question like, hey, does the point 2,3 satisfy this equation? Well, 2,3 is like over here, right? And so, oh, it's closer to the left, but anyway, it's on the right side over here. And so 2,3 does not satisfy this equation because it's not in the answer. And then also you could check your work by saying, hey, 3 is greater than 2 times 2 plus 9. Definitely not. So if I asked you for a point that satisfies this equation, you wouldn't give me like 2,3, which is outside of the area. You'd give me a point that's within this shaded region, like -6, 12 would be work. Let's try that one. So I could say possibly -6, 12 would work. So then I would plug that in and go 12, which is my y. This is my y. And I'd say 12 is greater than 2 times -6, add 9. So this is -12 plus 9. And yeah, it's going to be greater than, because 12 is greater than -12 plus 9, which is 3, -3. And so definitely greater. So you can pick any of those points and plug them in to verify that your answer is correct. Remember, the domain of a function is those set of values on the independent variable. Also, those are my inputs, my range, also my outputs. Identifying the domain and range. So we have a question like this. Your job is to find the domain and range. So when you're looking at this first graph right here, and I want to find the domain. Remember, domain goes left to right. And if this is a solid circle at -5, meaning for my domain, right, x, so all these values here would kind of scooch down to the bottom here. And because this is an arrow, it's just going to keep going over. So yes, it's at -5, it's a bracket, but at the same time, as it moves to the right, it's going to continue to be, to go to infinity. For my range, remember now my range are the values on the y-axis, and so what that's doing for me is it's saying, well, if I were to move all these values to the y-axis like this, and that's just going to keep going and going, everything's going to move over. And so what you're going to be doing with that is my range, including 3, would be bracket, and then that would go 3 to infinity. My domain and range for this problem here, domain dropping down to the x-axis, this is going to have actually a restricted value here. So my domain for this problem is going to go minimum 2, and because it's solid, I'm not just points, right? Remember when we just had points and we were saying, hey, this relation is a function, what's the domain and range? This, because of this solid line here, those are all the values in between. So if they were just points, you wouldn't use interval notation for 1. And number 2, you would just state those points. So this goes from 2 to 8, and it is including 8, so that's done. For my range, those values are going to go now to the y-axis, so I'm going to erase this, and then these values squishing over to the y-axis this way. All these values going to the right, or excuse me, to the left in this case. So my range, the lowest value on my range is going to be 4, but not including 4. And so that's going to go 4 all the way to 6, and it is including 6. Now remember, when you're writing these in interval notation, there is still that other notation, right, where you just write it out. And you could say, for the range, you could say that, I could say like this, and I would say y slash, and then I would say for y, for this value, because 4 is not included, I'd say 4 is less than y, And because this bracket is included, it would be less than or equal to 6. So that would be like another way I could write this if I chose to. For this problem here, my third problem, the domain is going to go from -4. Remember, these all go down to the x-axis. These all come up to the x-axis. So this would be from -4 all the way to infinity for my range. So the lowest value, see how this is going to keep going? So my range is going to keep going down, down, down. So -infinity, it's always bottoms, and then to the top. So -infinity to the top value, which is going to be to 5, not including 5 open circle. So for this problem, actually, you were supposed to write this in interval notation as well. I'm asking you to solve and write this in interval notation. So 2 things. Number 1, this is an AND equation, okay? This equation is an OR. It's either this side or this side. Whereas an AND equation is like the entire part in the middle, okay? So we're going to split this up like this, and I'm going to have 2 equations. So I'm going to say -5 is less than or equal to 1/2 times 3x plus 1. And then my other side of the equation is going to be 1/2 of 3x plus 1 is less than 8. And because I'm going to move this over so I have a little bit more room. So let's do that. Okay. And so in solving this problem here, let's see, for this problem first, I think what I'm going to do is I'm going to multiply that 2 out. So I really don't have to deal with that. Multiplying the 2, I'm going to have -10 is less than or equal to 3x plus 1. I'm going to subtract 1. I get 3x is greater than or equal to, if I subtract 1, that's -11. And then I'm going to divide by 3. So I'm going to get x is greater than or equal to -11 thirds. For this problem here, also, I'm going to multiply by 2. And I'm going to get 3x plus 1 is less than 16. I'm going to subtract 1. I get 3x is less than 15. And then x is less than 5. So I have 2 equations. And I'm going to box up my answers right here. So x is less than 5. And x is greater than -11 thirds. So after I box those up, now I'm going to graph these, okay? So I'm going to put 0 here. I'm going to put my -11 thirds here and my +5 here. And when I'm graphing these, what I'm looking at is x is less than 5. So that means this is open, less than. So all the values less than that up to this value, which says x is greater than or equal to -11 thirds. So solid circle here, and these are going here. So putting the answer all together, it's any value from -11 thirds all the way to 5. And so putting that in interval notation, the solid circle is a bracket, so it'd be -11 thirds all the way to 5, and that's going to be an open circle. For this problem here, again, 2 problems, right? I'm split these up. For this one, I'm going to subtract 1, so I get -3x is greater than, if I subtract 1 from both sides, 7 minus 1 is 6. When I divide by -3, though, remember this negative sign is saying the opposite of greater than. So the opposite of greater than is going to be less than. Remember, that has to switch. So dividing by -3, dividing that by -3, I get -2. So there's one of my answers already. For this side, I'm going to subtract 1 from both sides, and I get -3x is less than -6. Again, I'm going to divide both sides by -3, and doing that, this is going to flip as well. So we have x is greater than 2. So what we have here is draw your line. I'm going to put 0. I've got a -2, and I've got a +2. Again, the 0 is just like a personal preference. You don't have to put the 0 there if you don't want. That's up to you. So this side is saying x is less than -2. Open circle going to the left, less than. This value here is saying x is greater than 2. Open circle again, going to the right. So in order to put this in interval notation, remember, domain, all the values, they go from left to right. So this again is going to be left, which is parenthesis -infinity, all the way to 2, but not including 2. union, you've got this as a, let's see, 2, not including 2, and then that's going all the way to infinity, and then close the parentheses, not a bracket, parentheses. So for this kind of problem here, it's graphing the solution set. So we're going to graph this right here, and then they want to know what is the domain of x based on these 3 values. So each one of these is a different answer. So in solving this equation, I would split this up again because absolute values have 2 solutions. We have 3x minus 5 is less than or equal to 13, and we have the opposite of 3x minus 5 is less than or equal to 13. So I'm going to add 5. I get 3x is less than or equal to 18, x is less than or equal to 6. There's one answer. Now this one is saying negative 3x, you have to distribute that negative sign, plus 5 is less than or equal to 13. I'm going to subtract 5. So I get negative 3x is less than or equal to subtracting 5, what is that, 8. So I get 8. And then dividing by negative 3, I get x is now greater than or equal to negative 8 over 3. So graphing this, okay, so I'm going to graph this. Let's see, graph the solution set for each one of these. Okay, so they want a graph for each one. Okay, so here's, I will do my best to draw better. So let's see, a straight line, I can handle that. Okay, so real numbers, I've got my 2 answers. This is saying x is greater than, let me put this in here, negative 8/3. I've got my 0, and then I've got my 6. And so x is greater than or equal to, so solid circle, greater than going all the way to 6, and then it says less than or equal to, solid circle like that. Done. But then they're asking me to also graph this for positive integers. Okay, so what I'm going to do actually is I'm just going to move all this down so that I can put my graphs underneath that. Okay. So my next graph is going to look like this, right? And I can only talk about positive integers. Now think about this. Here's 0, here's 6, and here's negative 8/3. Now that is definitely not an integer. It's also, or sorry, positive numbers, not integers. It's not positive. And actually, even though this graph, right, goes from here all the way over to here, they don't want that. They only want positive numbers. Now you've got to ask yourself, is 0 a positive number? No, it's neither positive nor negative. So for this value, this is actually an open circle, right? And then it's all the values to the right, including 6, like that. Okay? Do you get that? And the last one is integers. And so if I were graphing this, so we've got 0, 6, and then again, negative 8/3. Now you ask yourself, what is negative 8/3? 3 goes into 8, how many times? 3 times 2 is 6. So that's like negative 6, no, 2. Negative 2, and then, so what that is, it's like negative 2, right? That's negative 6, and 2/3. Okay, so meaning this value is 1, 2, and 2/3. Negative 2 and 2/3. That's where this is right here, right? They don't want that. That's a fraction. We don't want that. We're talking about integers, meaning these values in between here, right? So what they're looking for your answer to be is this, not negative 2 and 2/3. Because remember, actually it's x is greater than, right? So it's, even though this is not a value here, you can't count that. That doesn't count. What counts, starting at negative 2 and not moving, just negative 2. Because they only want integers. They don't want they don't want the numbers in between. They just want the integers. So that's going to be this. It's going to be this. All of these up to 6. So I know that's not 6, but you can get the idea. That would be my graph for my solution set, which includes only integers. Okay. Here's a couple more axioms. Now we talked about axioms like commutative property, which is saying 5 times 6 equals 6 times 5. 2 plus 3 plus 4, right? And then if you rewrite this and you move the parentheses, so this is the commutative property of multiplication, right? This one, if I have the parentheses here and then I move them to the back, same answer, We call that the associative property. Then we had the distributive property, right, where you were to multiply some number outside by the values inside the parenthesis. That's the distributive. We talked about the identity property for addition, which is adding 0. We talked about the identity property for multiplication, which was a times 1. We talked about the inverse property of addition. So if I said 5, the inverse of 5 would be plus the opposite of 5. That's the inverse. It's opposite. The inverse for multiplication, if I said 5, the inverse for multiplication would be 1 over 5, right? Because those 5 would, it's the reciprocal. That's the inverse of that. So besides those axioms, and if you forgot all of those, go back to the notes from, I think it was day 1, and review those, because those are on your quiz for sure. These are some additional properties which may or may not be asked, but more likely the old ones will, but I did want you to just remind you of some of these that you have done probably in geometry. So for example, the reflexive property is basically said if x is a real number, then x is equal to itself. And you probably use this when, like, you were saying, like a triangle like this, right? And you were trying to prove this by angle, side, side, or whatever. And then you basically said that this line in the middle was congruent to itself because of the reflexive property. That's like what you would use. Symmetry, x equals y. Well, that's the same thing as y equals x, right? That's symmetric property. We have the transitive property is like if x equals y, y equals z, then x equals z. And trichotomy is just basically very simple, saying if you have two real numbers, one of these has to be true. Either x is greater than y, x is less than y, or x equals y. And this is like, I like this one, it's kind of cool, but because it's saying, hey, it doesn't matter what the outcome is, you will have one outcome, and these are your options, okay? This one right here is asking you to name all the sets of numbers. So we did this as far as, also on the first day, you need to revisit this. Name all the sets. Remember, there's real numbers, there's imaginary numbers, which this isn't. This would be an imaginary number, right? You have rational numbers, like this would be a rational number. You have irrational numbers, so that would be an irrational number, right? This would be an integer. This would be an integer because an integer is a positive or negative whole number. These would be counting numbers. This would be a counting number. It's also rational, right? It's also a real number. And it's a counting number. It's a natural number. What are the other options? I mean, there was like a whole bunch of them. You need to revisit that page and go back and talk about all the different sets that you think that this would belong to. And don't forget 2/3. Remember, 2/3 is not irrational just because it's a decimal. Remember, a rational number is saying that anything can be expressed as a ratio of two numbers. Now, I know this looks like a decimal, but if you write it like this, right, 2 3/10, and then convert that to an improper fraction out of a mix, you've got 23, right, 23 over 10. Now that can be expressed as a ratio of two numbers. So that is a rational number, not irrational. And then some other things to remember is like 0 is neither positive nor negative, etc. You also have to talk about naming these polynomials by degree and term, number of terms. And the number of terms are based on, like, is it one term? It's a monomial. 2 terms, it's a binomial. 3 terms, it's a trinomial. And anything more than 3 terms is actually just called a 4-term polynomial or a 5-term polynomial, like that. So this is a binomial, but if you look at this, it's x squared y. So remember, you have to find the degree, you have to add the values of the exponents if they are multiplied. Only if they're multiplied, okay? Meaning, if I had x to the 5th here plus 3x squared, the degree of this term right here would be a 5th degree. Remember, that's a quintic, but this would be a 5th degree, and it'd be a binomial. We don't add those two exponents because they're not multiplied together. So it's just the highest power. Also, the highest power denotes the leading term. So x to the 5th would be my leading term. And then if I asked you what my leading coefficient would be, it would be 1, the value in the front, okay? Don't forget also that even if there had been a number in front of this, and let's say I said that was 6 to the 7th power, you do not count coefficients, or you don't count the numbers, the actual numbers in front of the variables. They don't count, okay? They don't. So this right here, let me erase that. So getting back to the problem, this is a third degree. So a third degree, right, is called a cubic. And because I have two terms, it's a binomial. This one, oh, by the way, is not a polynomial. And the reason why is because you're dividing by a variable. No variables are allowed on the denominator. Also, this is not, because it's not a polynomial, because again, you can't have a variable under the root. So sometimes I've seen on like tests, like big tests, like, you know, SATs and stuff like that, where they do something like that and they're saying, hey, is that a polynomial? Well, that's a polynomial. I mean, it looks like, but see that x is actually not under the root. So be careful of that, all right? That would be, yes, a polynomial, because the x is not under the root. Okay, this one right here, this is not a polynomial because it's a square root of a negative number, which is imaginary. That can't happen. So that's a no. This one right here, you can have a square root of a number, but just not an imaginary number. So this is going to be a fourth root. So 2 plus 2, that's 4. Fourth root, or we call that quartic. And because I have two terms again, it's a quartic binomial. This one also is a quartic, because remember the 4 doesn't count. So that's 2 plus 2 again is a quartic. But this one is called a quartic monomial. This one here, it looks like it's a squared. That's a 1. And remember that x to the 0 power, which we don't count. That's going to be a second degree. So a second degree we call a quadratic. And 3 terms makes it a trinomial. This one right here, which is an absolute value, is not a polynomial. Again, because if you think about it as the graph, right? If you think about this one as a graph, remember polynomials have to be continuous. They can't have any sharp edges. So if you guys look right here, right? That's sharp. That's a pointed edge. That's not a polynomial. It's not smooth. It's not consistent. Can't do that. This one right, where's the other one? The square root one, remember the square root? That's just this, right? It's not continuous. It stops. Likewise, the value that has a y on the denominator or an x on the denominator, that's not a polynomial, because remember that graph looks like this, right? 2 parts with an asymptote in between. It's not continuous, therefore it's not a polynomial. Part of the test right here is they're going to ask you to come up with determine whether this relation graphed, is it a function or not? And remember, it has to pass the straight line test. Okay, so that means for every value of x, you can only have one value of y. So we have, this does pass, so this is a yes. Doing my straight line test, that's a no, because I see how I'm intersecting in 2 places. That's a no, not a it's not a function. For this one right here, this is a definite no. This one also a no, because think about this. If I use my straight line test like this, right? See how this is solid and this is solid? It's intersecting 2 times. So whatever value this is, I have 2 values of y. You can only have 1. This does look like, you see how many emails I get? You know, all these. So this definitely would be a function. So we're going to say function. That's a yes. This is a yes, because doing straight line test, right, totally works. This is a yes, because look, if I did my straight line test like that, this is an open circle, that's a closed circle. 1 value of y, okay? Function, yes, because see how it goes like this? Still not going to touch. if these were to cross, so that yes is a function. No, it's not a polynomial, but that wasn't the question. The question is this a function? The answer is yes. This one doesn't pass the straight line test, definitely not. This is a no for sure, because look at this. This straight line, it's like made up of a straight line. That's a no. We have like an infinite number of y values. For this one, this is a yes. That solid circle, when I bring it down to here, it's only actually intersecting once. So that's a yes, and then also another yes. Cool, okay. This one is just solving some more inequalities, and yes, you have to know these, obviously. Let's do some more. We're going to subtract x from both sides. We get 4x. I'm going to add 6 to both sides. What is that going to be? Greater than 12. So x is greater than 3. So graphing this, here's my 3, here's my 0. X is greater than that. Open circle, values to the right. If I was putting this in interval notation, I would go parenthesis 3 to infinity. And so, like I said, I like that you have to be able to know all the different forms. So you do have to know algebraically, you have to know graphically, and you also have to know interval notation, which this includes all three. This one, again, has two parts to it, right? This is your and. So you've got -3. Oops, let me fix that. You've got -3 is less than 1 minus 2x. And then you've got 1 minus 2x is less than or equal to 3. So I think the tricky part for this problem is that you have to be able to see this. Like, you have to be able to see that this is an equation right here, and this is an equation here. You have to be able to distinguish that those are two separate equations. So sometimes it's hard to read my writing. Okay, so I am going to, I guess I'm going to subtract 1. So subtract 1 from both sides, I get -4, that less than, and I get a -2x. I'm going to divide both sides by -2. And I'm going to get x is less than, because remember, hello, this is opposite of the inequality. So opposite of greater than is less than, and then that's going to be 2. So that's one answer. The other one, subtract 1 from both sides. I'm going to get -2x is less than or equal to 2. I'm going to divide by -2, so that's going to give me x is greater than or equal to -1. I'm going to box that up. I'm going to get, graphing that, so I got a 0, I've got a 2, and I've got a -1. And so when I'm graphing this, this is saying x, read the variable first, x here, see that? X is less than 2. So open circle that way. This one says x is greater than or equal to -1. Solid circle going to the right. So if I ask you to give me a point that satisfied this equation, you would say any value including -1 that's less than 2. So any value in between that area would be correct. Putting this in interval notation, we would say bracket -1 to 2. Parenthesis. For this one right here, we're going to solve two different equations. 2x is less than 8, so I'm going to divide both sides by 2. I'm going to get x is less than 4, box that up. Subtract 3 from both sides. I'm going to get x is greater than or equal to 7. I'm going to box that up. So what this looks like, I'm going to draw my graph, and drawing this graph, it looks like I'm going to put my 0, my 4, and I'm going to put my 7. It says x is greater than or equal to 7. So it could be equal to 7, solid circle, going to the right. This one says x is less than 4, not equal to, open circle, going to the left. So the reason why the or is there, you guys, is because while these are the same problem, and you're fitting this on the same graph, it's a union of two equations. What they're saying is your answer could be this or this. You can't have both, right? Or it could be this or this. It's not going to be that and that. It's going to be together as one graph. So let's put our interval notation. So parenthesis, this left to right. Remember, -∞ to 4, parenthesis, because that's an open circle. Same time, we have 7 bracket to infinity parenthesis. All right. So basically, for tomorrow, tomorrow and Friday, Thursday and Friday, we are going to be doing this review in class. You also have a review worksheet. So while this didn't take that long to go over, if you want to stick around and do some problems from the worksheet, I'm going to be available for that as well. And you're going to be able to take your quiz right after that. So thanks for watching, and I hope that this helped you.